how do you find the rectangular form of a parametric equation? And what does the graph look like? What does time have to do with anything? How does it affect the graph? Well, thankfully, some students asked the question, and this video is demonstrating my response to that particular question. That we want, they ask using algebraic method to eliminate the parameter, identify the graph. Okay, so let's eliminate the parameter first. What we want to do is to solve for t in either the first or the second equation. So we basically pick. All right, so we have t in the second equation. So the t that we have here, we're going to go ahead and substitute it here. So we're going to say that basically now we have y equals 9 minus 4 times the value of t, which is all of this right here. So you're going to put x plus 3 over 2. All right, you guys with me on what just happened?
Yeah.
Okay, so now next we're going to multiply this 4 times what we have here. What do you suppose is going to happen with these two?
You're going to distribute the 4 to...
Good. So this is saying multiply by 4, and this is saying divide by 2. So if we took anything and multiplied it by 4 and then divided it by 2, basically we're ending up with what? Once we get here, we could say y equals 9, and then we distribute that negative 2. Okay, and then 9 minus 6 is 3. So now we have y equals 3 minus 2x. So this is what they were looking for when they said to eliminate the parameter. You could also write this as y equals negative 2x plus 3.
So is that a parametric equation?
So these two, that's a parametric equation.
I'm sorry.
That's okay. All right, so this is what we call a parametric equation. Basically 2 equations with the third parameter being t, or time.
Okay,
No.
and what...
Go ahead.
No, it's okay. I think you're about to say it.
And then this one right here is the normal or rectangular form of, you know, when we graph things, like if we graph a point x, y, we're literally going x this way and y this way, or we can say, it would be weird, but you could go y this way and x this way. And so you end up forming a kind of rectangle when you graph at any point. So the normal way of writing stuff in terms of x and y is called rectangular, whereas this way, where we're using an extra parameter, which is t, this is called parametric. All right, so do you guys understand the first part of it, how we got from the parametric to the rectangular?
Yeah.
Okay, all right, good. So we eliminated the parameter. All right, so then it says, identify the graph of the parametric curve. So when you graph this equation, what's it going to turn out to be? Like, what is this when you graph it?
That's going to be a line.
It's a line, right? So this is a line that has a parametric attribute here. So if we were to graph this, we could say, okay, the y-intercept is 3. The slope is -2, which means that we would go down 2, right 1, down 2, right 1, down 2, right 1. Does that make sense to you guys?
Yes.
Okay, so we expect that we're gonna have something like that. The thing though is, and the question doesn't necessarily ask for it, but if you wanted to find out what direction this is going in, because as soon as you include time doesn't go both ways. Time only goes forward. It only goes in one direction, right? Does that make sense?
Yep.
Can't go backwards in time, only forward. So this whole setup here, which is the same as this whole setup here, has a certain direction that the points are going to go in. So as an example, if we want to figure out the direction, we could say, well, what happens at the beginning or time equals 0? So if we substitute 0 in for the x part of it, so if t is 0, 2 times 0 is what? What I'm saying is we're taking some values of the time just to test to see what direction we're going in. And we don't need a bunch of them, but I just want to give you guys a sense of what's happening here. So if we plug in 0 for the x, we're basically saying 2 times 0 minus 3. So this part is 0, minus 3 is -3. So if I plug in 0 for this x equation, I'm going to end up with -3. Does that make sense?
Yeah.
And if I plug in 0 on the y equation, I'm just going to end up with 9. And then if I plug in 1 here, 2 times 1 is 2, right? And then subtract 3, that's what? -1, right? Let me write it out. So if we substitute 1, then that's going to be 2 minus 3, which is -1. And now if we go to the y part of it and we substitute that, so we have 9 minus 4 times 1. So this is 4. Subtract 9, subtract 4 from 9 is 5. So we're going to have 5. And we can keep going like that. So if we plug in this 2 for t in this equation, we'd end up with 4 minus 3, which is -1. If we plug in this 2 right here, we'd end up with 8 here. And 9 minus 8 is 1, so that's 1. And if we plug in the 3 here, that'll be 6. And 6 minus 3 is 3. And if we plug in the 3 here, that'll be 12. And then 9 minus 12 is -3. So if we were to take these points, which these are not points, because that's x, that's y. That's x, that's y. That's x, that's y. So t equals 0 means that's where the first point is, because time begins at 0. Then this would be where the next point is, and so on and so on. So this tells you what order the points go in. So the first point would be at -3, 9. Okay, so -3 is over here somewhere, and then 9 is up there. So this is the very first point. the next point would be at -1, 5. So -1 is over here somewhere, and -1, 5 could be here. So this is where the next point is. And then we have -1, 1. Wait a second, that can't be right. So yeah, this was supposed to be a +1. Does that make sense?
Yes.
Okay, so it's a +1. And let's just check this one because I may have made a mistake on that too. If we substitute 2 here, 4 times 2 is 8. 9 minus 8 is 1. So we have 1 here. So if we plot this point, 1, 1, so 1, 1 could be over here somewhere. So that's where the third point is. So what that tells us, and we could do this, the same thing with this last point too. So 3, -3. So 3, -3 is over here somewhere. Basically, that's the first point. That's the next point. So everything is going in this order. So we can put some arrows here to say that that's the order. But that's the only difference between graphing a parametric equation and a normal rectangular, is that as soon as you include the time, then that's going to tell us basically what direction everything is going. This one specifically says it's between t equals 3 and 5. So the difference in how it should have been done, because I'm going to tell you the truth that I did this and then afterwards realized it said that t was between 3 and 5. But what should have happened was, as opposed to me starting here at 0, I should have started at 3. So I should have maybe done 3, 4, 5, and then gotten the points and then figured out the direction. You guys still want to see that part, or do you get how that works?
Can I see that part?
Sure. All right, so let me give me another paper here. So what we have are these equations, right? X equals 2t minus 3 and y equals 9 minus 4t. When we come up with the table that tells us what order everything goes in, we're going to say t is one of the parameters, and then x and y are going to tell us the points that we get at each time. So this time starts at 3. So we're going to start it at 3. And I could have decimal values in between, but it's just that integers are easier to work out. So I'm just going to plug in t equals 3, then the next integer up, which is 4, and then 5. You guys follow?
So you start from the lowest to the highest?
Exactly. All right, so t is 3, so I'm going to take that 3 and substitute it here. So x equals 2 times 3 minus 3. So that'll be 6 minus 3, which is 2. Does that make sense?
Mm-hmm.
Okay, so at time equals 3, the x part of it is going to be 3. We want to get the y part of it also. So the y part of it is 9 minus whatever 4 times t is. So we're figuring out for t equals 3 seconds. So we're just going to plug in 3 right here. So 4 times 3 is 12. 9 minus 12 is -3. So we're going to plug in -3. So that means that the first point that we're going to have from what they ask us to graph is, the first point is going to be 3, -3. All right, does that make sense?
Yeah.
All right, so the second point, we're going to plug in this 4 as our t value in both equations. So x equals 2 times 4 minus 3, so that's 8, minus 3, 5. And on the next one, 9 minus 4 times 4. So what would this one be?
-7.
Okay, good. So we have 5 and -7. All right, so could you describe to me then the process that we'll use to determine the final point?
Plug in 5 to both equations.
Okay.
So
So what would that look like? X equals
2 times 5 minus 3.
mm-hmm.
You get 7.
Good. And then
And 9 minus 4 times 5. And you get -11.
okay, so we have 7 and -11. Okay, and I don't have graph paper, so like I said, what I'm doing is basically just a sketch. But the equation that we got, the rectangular form equation, was this one. So if I sketched it, then I would start at 3, and then I'd have this, right? So if we were to, and I put it as dotted because we're not going to need this whole thing. We're just going to need where it starts. So it's going to start at 3, -3. So at 3, -3, maybe that's 3, -3. That will be the first point, right? Where the time is 3. Does that make sense?
Yeah.
All right, so the next point is this one here at 5, -7. So 5, -7 could be here. So this is where t equals 4. And then finally, where t equals 5, that one is 7, -11. So 7 could be over here. So this is where t equals 5. So basically what we know is that, you have a question, Ms. Opal?
Oh yeah, after you're done like with the graphing, I just had another question on how to change parametric functions back to rectangular. I think
Okay.
that was good.
Okay, no problem. All right, so when we do this is the first point, that's the next point. So basically this is the order everything is going in, right? So that means that that's the order. This is the part, I'm gonna make it solid now because that's the part that we actually need. And you can draw as many arrows as you want to, but that's basically the direction. So this is our parametric equation. All right, you okay with that?
Yes.
Yes.